Today, we're looking at a submission called Thinking with Video, which uses models like Sora-2 to try and unify visual and textual reasoning. We found this work really compelling.
Oh, incredibly so. It's a genuinely new direction, moving these huge video models from just, content creation into actual reasoning. A big step. But okay, let's dive right into the first piece of high-level feedback.
Right, so the presentation of your text-centric results inadvertently creates a central contradiction that challenges the paper's primary claim, that thinking with video is a unified multimodal paradigm.
Exactly. You start off with these really impressive numbers.
Yeah, you see Sora-2 hitting 98.9% accuracy on a math benchmark like GSM-8K just from an audio prompt. And you think, wow, something amazing is happening here.
It is an amazing score, no one's denying that. But the problem is that number, as good as it is, starts to unravel when you look at your own analysis, the one you wisely included later on.
That's the key. The weakness isn't the score itself, it's that your own control experiment suggests the intelligence, the real reasoning, isn't actually happening where you claim it is.
And we should probably spend a second on this prompt rewriter because it's so central to the issue.
Good idea.
So as we understand it, there's this upstream model, a VLM, that basically cleans up the input before it even gets to Sora-2. And your analysis shows that if you turn that rewriter off,
The accuracy just craters.
it goes to nearly zero across the board on GSM-8K, MMMU, all of them, which, strongly suggests that the high score comes from a pipeline. The text-to-text reasoning is already done before the video part even starts.
Right, so it's not a product of the video model's own understanding. And that's the crux of it. You've built a very successful, a very clever pipeline, but the results don't quite support the claim of a unified paradigm. The high score is sort of undermining your thesis.
So what's the fix here? How do you suggest they handle that?
Well, our suggestion is to reframe the conclusion of that whole section. Instead of using those big scores to argue for a unified model.
You do the opposite.
Exactly, you pivot. You argue that the failure of the model to generate visually coherent steps is the real finding. It proves the current setup is just a pipeline, and that true unification is still the big challenge ahead.
I love that. That's a much more powerful narrative. You're not defending a claim that's maybe a little shaky. You're defining a massive research problem that you've just uncovered.
It changes the story from we've solved it to we've diagnosed a fundamental structural weakness, and now we know what to build next.
Okay, so for some concrete examples of how to do that, you'd want to, downplay the 78% overall score?
You'd soften the emphasis on it, for sure. And instead, you put the spotlight directly on the dramatic visual failure.
You go straight to that qualitative data. I'm thinking of figure 6.
Yes, that figure is damning. In the best way. You have to highlight that contrast. The model gets the right number in the audio, but in the video, only 13.9% of the visual steps are actually correct?
And even worse, that huge number, 43.48%, was just unreadable or incorrect logic.
That visual breakdown is the critical finding. You present that as the diagnostic data that proves we need to move beyond pipelines. That's how you justify the next generation of models.
So you frame the current textability as an engineering win, a great pipeline, without confusing it with the core mission of the paper. That makes a lot of sense.
Okay, let's move on to our second point. This is about maximizing the narrative power of the dynamic reasoning, especially for the vision-centric tasks.
Right.
The presentation of vision-centric task performance should foreground the unique dynamic reasoning advantage, rather than relying primarily on static accuracy comparisons with existing vision language models.
This is where the whole idea of thinking with video gets really exciting, philosophically. Static images just can't show a process. They can't show something being built or changing over time. Video can.
It should be a completely different ballgame. But the weakness in the current draft is that you often just present Sora-2's wins as slightly better average scores.
Like the eyeballing puzzles. You show 40.2% for Sora-2 versus 35.1% for Claude 4.5.
Which is better, it's a solid result, but just putting those two numbers next to each other kind of minimizes the whole point. It makes it seem like you're just playing the same game as the static models, just a little better. You're competing on their turf. Suggestion here is to systematically use the great performance on tasks that absolutely require construction or temporal steps. Make those the centerpiece.
the ability to simulate drawing, to visualize a process. That needs to be the whole story in this section.
So you're looking for the tasks where a static model would just completely fail because it can't literally show its work over time.
Precisely. For a concrete example, you have to lead with the ray intersection puzzle from Table 2. That one is just perfect.
That's the one where it has to actually extend the lines to find a point that's off the original image, right?
Exactly. A static model can guess, it can infer, but it can't show the process. Sora-2 gets a stunning 88% accuracy on that. It's actually visualizing the solution.
And when you compare that to GPT-5 High, which only got, what, 16%?
That's the headline. That 88 versus 16. That one comparison tells the entire story about the unique value of thinking with video.
And to make the argument even stronger, you should also be really clear about the current limits. Show the boundaries of this new capability.
The maze-solving data is perfect for this. You should absolutely highlight that.
Right, because it shows a 40% success rate on simple square mazes, which is pretty good.
But then it drops to 0%. 0 on the hexagon and circle mazes.
And that contrast is so important. It doesn't weaken the paper. It strengthens it by showing exactly where the reasoning breaks down today. It says, look, we've achieved this, and we know exactly what we need to tackle next.
It's using failure as a compass for future research. That's always compelling. Okay, let's pivot to critique 3, which is about the methodology.
I thought this part was genuinely innovative. The methodology you introduce, specifically major frame evaluation and self-consistency, should be framed as a novel and necessary contribution to the field of video reasoning evaluation, not just a detail of your setup.
I could not agree more. The insight is so important. When you have a dynamic, generative output, you can't just trust the last frame. The model's real intent is best seen over time, with the major frame method, or across multiple tries with self-consistency.
But the weakness is where you put it. It's kind of buried inside the results sections, like it's just another part of the experimental setup. And that really diminishes its significance. Developing new evaluation tools is a huge deal, especially for a medium like video that's so noisy.
Yeah, you really need to pull these methods out and give them the spotlight they deserve.
So the suggestion is what? To elevate them?
Yes. Treat these temporal evaluation methods as an inherent, necessary feature of the thinking with video paradigm itself. The argument is simple. A dynamic output requires a dynamic analysis. You have to frame the major frame method as a powerful tool for diagnostic denoising.
That framing is great. It's not just a trick to get a better score. It's a new standard for how to measure these kinds of models. If you're building a new kind of engine, you also have to build a new kind of dynamometer.
Exactly. And for a concrete example to back this up, just pull the data from the ARC-Connect puzzle in Table 6. This is where the power of this method really shines through.
Okay, so let's just explain major frame evaluation a little more clearly. Instead of just looking at the very last frame of the video, which might be messed up.
A visual artifact or just unstable?
Right. You sample frames throughout the video, say every 5 frames, and you take a majority vote on what the answer is. It's like asking a model for its opinion over time.
And the impact is huge. On that ARC-Connect puzzle, using just the last frame gets you 56% accuracy. But with major frame evaluation by sampling and voting,
It jumps to 68%.
that's a massive leap in reliability. You need to explicitly call that denoising in the text. It's proof that your method is filtering out the noise and finding the true signal of the model's reasoning.
And then you show how to make it even more robust by combining it with test time scaling. When you use major frame analysis and self-consistency, taking a vote across 5 different attempts, the accuracy goes from 68% all the way up to 90%.
An incredible jump.
And that establishes a clear principle. Temporal consistency, both within a single video and across multiple videos, is a really strong proxy for model confidence. That's a major methodological contribution for the entire field.
This is just fantastic work overall. You've laid a really strong foundation for this thinking with video idea and shown that these models can be powerful reasoners.
Absolutely. You've demonstrated a unique capability for dynamic problem solving that, static models just can't touch.
So to maximize the impact here, our critique really boils down to 3 main actionable steps. First, tackle that central pipeline issue head-on. Reframe the narrative so the visual failures in the text tasks become the core engineering challenge you're trying to solve.
Second, really amplify that dynamic reasoning advantage. Don't just show average scores. Lead with your most dramatic wins, like that 88% on ray intersection, and use the failures, like on the complex mazes, to clearly define your research frontier.
And finally, elevate your methodological work. Frame major frame analysis and self-consistency as the novel, necessary evaluation tools they are. Show that you're not just building a new model, you're building the right way to measure it.
We strongly encourage you to refine the work based on this critique, and we'd be very excited to see the revised version for a follow-up discussion.